Now we are moving into the advanced track for everyone operating object storage at its limits. Please welcome Ansgar Jazdzewski, object storage engineer at Hetzner Cloud. Ansgar has over 10 years of Ceph experience and is responsible for building a cost-efficient petabyte scale platform there. His talk, Scale Multiple Cluster, Ceph Cluster Horizontally, addressed the challenge of what happens when a single cluster reaches its practical growth limits. He will talk us through the architecture, how to configure HAProxy and seamlessly connect multiple Ceph clusters into a unified frontend. Prepare for a deep dive and honest insight into the real-world challenges. Welcome, Ansgar Jazdzewski.
Hello, thanks for having me. So, yeah, obviously that's me. I will go a little bit through why we do this. So, first of all, we at Hetzner have like logical physical space limits. So a cluster can have a certain size until it becomes like unpractical to be used, to be maintained in a way. Also, we had to do some considerations on a blast radius. So if you have a cluster, there's no secrets. From time to time, things happen that you have not had expected. So we do not want to have all customers facing an issue while one of our clusters have this issue. This is especially true if you do like rebalancing and have like recovery traffic and those kind of things. Eventually you will be able to maintain this in a way that important customers you can take on a little bit early on and kind of move them with their workload to a cluster that is maybe not that affected at the moment. And especially interesting is that for maintenance windows. So again, important customers, for example, or workload that we know will be harmful during a maintenance, we can try to move it away. So really quick, like a 10,000 feet high-level view of the infrastructure, what we built. So we have the internet where our clients usually use their S3 clients to access our S3 product, basically. And what we have done, we have created a control plane where we have all our buckets that the customers have created, and we store an information there on which Ceph cluster these buckets live in, basically. And then we took a pretty neat approach with HAProxy. HAProxy does allow to implement some plugins using Lua. And I will go a little bit into detail how this is working. So what we basically do is we identify the bucket, ask our control plane, and pick the right backend in our HAProxy to then delegate the traffic over to the correct cluster. So the challenges we had to overcome is like select the correct location for the customer on the point in time where they request the new bucket. So that's a selection we had to do, like, is the cluster healthy? How much space does the cluster have, etc. And then we also had to think about, okay, what will happen if a cluster is full at some point? So do we want to add more hardware to this one particular cluster to scale it? Or do we want to be able to move that bucket or another bucket from that cluster over to another cluster just to make room in the source cluster? We decided to go with this approach simply because, again, the blast radius and the physical limitations that we have in the data center. So you can imagine that having like a rack and then add a new server that's like 300 meters away in some corner of the data center makes not really sense, especially if you then have your remote hand service folks there and you have to tell them, yeah, that's not over there, you have to go over there, and then management of the network becomes a nightmare as well. So we try to avoid this. So yeah, basically HAProxy in Lua. So how do we do this? And that's basically the secret sauce here that is needed, and that's the one that is kind of easy to share. And there I will go a little bit into detail. So what we need to do, first of all, we need to identify the bucket name from the request. Second of all, we need to somehow send it over to something Lua and then get the correct cluster back, which is relatively simple to get the bucket name because S3 basically has two ways of doing it. There's the domain style, which is nowadays the default, but still not used everywhere, where the bucket name is the first part of the DNS name. And the second option is the path style, where the bucket name is the first directory of the path of the URL. So this can be kind of easily done in HAProxy. You basically look, okay, is the domain in the style of the DNS path? And if so, we extract this. And if not, we take the second word. So we split it by / take the second word, which is then the part you are looking for. And then we basically can set this into a variable and then ask Lua to give us the result. And we also, for debug purposes, we put this into a variable just for the sake of it. So we have this variable, we have sent it to Lua. Next question is, what is Lua? How complicated is it? And it's surprisingly easy. So what we need to do, is there a slide missing? Yeah, there's a slide missing, so the export didn't work, so sorry for that. So what we need to do is we need to, first of all, connect to a Unix socket. So how our approach works, we take the request, we send it to the Lua code then writes a request to a Unix socket. On the other end of the Unix socket, there's a microservice written in Go in our case that then communicates with the database to make the lookup and also some caching and stuff. So that's like the data path here. So first of all, just load the extension. That's straightforward. Second, we came up with a protocol, if you will, that's slightly inspired by Memcache or Redis. So what we do is we have like a magic string, get space bucket name, and we expect a response out of it. So, and we simply send this to the Unix socket. So that's really kind of the live code already. I skipped some parts for error handling, but that's what we use. And then the other thing is basically we look into what came back from the Unix socket. And that's not how Redis worked. It will just respond to string. We decided to then inspire ourselves a little bit on HTTP. So we say if it is a positive result, we give it 200 space and then the name of the cluster brick. So what we do here is we look for 200 space. If that is, then the rest of the string is obviously our backend that we will use in HAProxy. And this is basically the last line. Then we'll set the backend variable that then later on can be, again, simply used in HAProxy to pick and choose the correct backend. One other thing that you have to do, again, it's all documented with the HAProxy documentation. You have to load the Lua module to HAProxy so that it is available in your HAProxy configuration, and that's simply, basically tie the Lua function to your HAProxy environment. Another thing, and that was also like lessons learned from us. So the documentation normally says load Lua, which will work, but then the Lua code will only work on one thread within the HAProxy. So what you really want to do is you want to use this Lua load per thread. So each individual HAProxy thread runs the Lua code as well. That massively improves latency and throughput overall. So just as a takeaway, forget load Lua. That's the way to go. So basically what we have as of now is we have an existing bucket that we can store an information in a database where the cluster, where the bucket is on which cluster it is. However, we also need to create the bucket in the first place. So we need to come up with an idea how we make sure to find the right place for the bucket. And that we do in HAProxy kind of as well. So, oh dear, I'm so sorry that there are really slides missing. But I can go through it and I will make sure that the correct slides are then uploaded to the conference page afterwards. So to create and delete a bucket, we need to first of all create an ACL in HAProxy. Then we need to send the request to a microservice. And this is simply done by, okay, we look for the nitty-gritty details of the S3 request. So when you have seen my workshop yesterday, you have seen that create bucket is basically a put request with a name onto the endpoint of the S3. The same is true for deleting a bucket. So we have to look for put requests and we have to look for delete requests. The next thing we have to do is we have to, again, look for the domain style or for the path style if there is just the bucket name in the URL. So either it just ends with a slash or it just ends with a bucket name and a slash. And then we have to kind of put this together again. It's just so we can check, okay, we only are on the root here. And then what we do next is we look for a create bucket or delete bucket request doesn't need to have the S3 authentication header because you cannot have a non-authenticated request to do so. So we simply check if the header is there. And then we look, okay, if it is a create request, then we must have a put. It must be a put. It must have an authorization, and it must be the bucket root. And for delete, just the same with the delete request. And then we can simply pick and choose our backend based on our ACL. So we can say, okay, use the backend create bucket if it is a create bucket request. Do the same if it would be a delete bucket request. So there's no magic, and then you run your service somewhere. So, and this service then has to do the magic trick to create and delete the bucket in your S3 environment. So we get the bucket request from our HAProxy to the service. Then we have to validate the request. So we have to check if the secret key, if the authentication header was signed by the secret key based on the access key of the request. So basically we do the signage in reverse just to validate this was the valid customer that did the request. Then we basically have to find the right cluster where to put the new bucket to, which is we send a message out in Kafka asking all our clusters, there's an agent installed, hey, how are you feel about creating a new bucket for us? And then they respond with, we call it willingness. So it's like a value in percentage. 0 is like, I don't want to take a new bucket. Or like it's 100 then, or 256, I guess. I don't know how we did it in detail. Anyway, then it will tell you, hey, yeah, I will take this bucket. And we wait for a couple of time. So we get a bunch of responses from the clusters, and then we will pick and choose the one that had the highest willingness to take the new bucket. And then, of course, we have to update the DB, so we have to store somewhere the information where the actual bucket goes. And if we have done this, we then reach out to the cluster, again with a Kafka message, to then create the bucket in the cluster itself. So if you think, oh, that sounds asynchronous and it might be slow, no, it isn't. It's actually quite fast. There are challenges, I will point them out later, but it works good in the most cases. So why do we do this crazy, complicated approach? So first of all, as we have multiple clusters in multiple data centers and we do not merge them overall, but we want to limit our customers how much buckets they can create regardless of the region or cluster, we have to count the number of buckets that a customer has created somewhere. So with this approach, as our microservice creates the bucket for the customer, we can simply count it and then apply a quota for our customers. Also, and that's maybe the more important part of it, is we can offer our customers a unified view on their S3 environment. So we have the Hetzner console, it used to be the Hetzner Cloud Console, now it's the console, and there you have a section where you can manage your S3, and there you can create your buckets. And in the back end, this will utilize the same microservice to create the bucket that an S3 API call would do. So it's the same underneath, but you will see it on the website as well as using the API. Yeah, next thing is the bucket migration, and there it becomes really, really interesting on how we need to do it. So again, we are limited on the cluster size. We don't want to grow it bigger than that. So we have to create additional clusters. So we have to migrate the data at some point from one cluster to another. So that's especially true if we run out of capacity on one cluster, or if we have like noisy neighbors that do crazy stuff, and we want to like balance the utilization of the clusters from an I/O perspective as well. So for that approach, we use multi-site. So Rados Gateway multi-site is, let's put it that way, it's tricky. It's usually overcomplicated, and it not always does things in a way you would expect them to do. So I will not go deeply into multi-site here because that would be a talk of its own. What we do is we have disabled the default in multi-site, which will move all buckets from all clusters inside the multi-site region. So we only focus on metadata, which is basically the bucket names, the bucket IDs, the users, and their keys. So they are in sync across all the clusters within one region. One region is one data center. So it's like Falkenstein, it's Nuremberg, or Helsinki, for example. So how you do this is basically you have to create a sync group that will tell the cluster to not to do the default, which is enabled. You have to tell it it's just allowed. So that's the trick, that it will only synchronize the metadata but no data. So what we have to do next is we have to create a default pipe. That's kind of optional, but it feels better when you have it. And then we can basically focusing on moving a bucket. So that was just the 2 slides on multi-site. If you want to go into detail how to do it, again, it's a little bit tricky. So if we want to move a bucket, we have to identify a bucket. We have to create a pipeline for that bucket. We have to run the actual sync for the bucket, so we have to move the data. Then we have to change the database entry that will later then tell our HAProxy, hey, you now have to make all your put or get requests not on this cluster, but on the other one. And last but not least, we have to delete the data on the source side, which is also a challenge. Simply, if we would just copy the data, we would not make space on the source cluster, which is the overall goal of the entire task here. So how do we identify our buckets that we want to move? So the easy choice would be, yeah, just take the bucket that's currently growing the most. But that's maybe a bad idea. So we want to move buckets that have a medium size. So moving a multiple terabyte bucket takes time. And you want to be able to delete the data on the source bucket fast. So you have to finish the entire process really fast. So you don't want to move the biggest buckets, but you also don't want to move the smallest buckets because that will not have an impact on the cluster capacity. So medium size is what we're looking for. The other thing that we look for is the traffic on that bucket. So we want to ideally move buckets that have close to zero traffic. So that's just a backup sitting there when the customer will eventually use it at some point. And then we have to look into the features that are used with the bucket. So like legal lock, retention policies, versioning, encryption, all those features. And we kind of want to take the buckets that are not using them at all, because otherwise we have to look more into detail, is the synchronization done correctly? Because unfortunately Ceph and especially the Rados gateway still has bugs in those features, so we like to validate them one after another, so we create test buckets using certain features and make sure that they work. So for now, we try to just use simple buckets that do not use those features. Basically, the next step is we have then to do the actual preparation for the synchronization. So again, we create a group for then this particular bucket that we want to synchronize. We create the pipeline from the source to the destination. Remember, this is already a working multi-site setup. So you have to have a working multi-site Rados gateway setup at that point. And then the tricky part, and also like the how to initialize it, is basically run a Rados gateway bucket sync run, which is, by the way, something that's not really well documented that this is even existing. And then you say, okay, sync it from this zone over to another one. And when we are done, we simply remove the sync group. So in the step between this, we would change the database entry and we would wait some time, so to make sure that the customer is not complaining for whatever reason, so we would not delete the source data immediately. And then we delete the sync policy after that. And then we can start deleting the data. Deleting the data is a challenge in itself, because you might think the easiest way would be to just add a retention policy to the bucket, to the source bucket. Unfortunately, this retention policy gets replicated to the new destination as well. So what you have to do is you have to use Rados gateway admin commands to delete each individual object, because you can also not use the delete bucket with bypass garbage collection and stuff, because this will happen on the destination side as well. So that's an issue. So what we look at, and we kind of ask already with the community and stuff, is that there hopefully will be a bucket erase command or something like this, so that we just have one command that will do a fast deletion of the data within a bucket without deleting the bucket on the source side of the synchronization. So basically what this gave us is now we can horizontally scale Ceph clusters, moving the data along, handling blast radius, handling the maintenance windows and all those stuff, and we can simply add just new clusters to our data centers whenever we run out of capacity in one region. Yeah, but this comes also still with a lot of challenges that we still need to overcome. One of the most asked questions from our customers is, hey, we want to have custom domains. So a customer would like to have their own domain name where they put their static hosted website on, for example. But this is not as easy as it sounds. So how do we figure out the bucket name from this custom domain? Right? We have to resolve the C name that points to the bucket, but we do not need the IP address. We need the step right before that. So eventually we can just store the entire custom domain in the database and then make a lookup over there. The other challenge is each of those custom domains, as we only allow HTTPS, we have to create certificates for each individual domain at that point. So you can imagine you have like an HAProxy setup with a couple of HAProxies, but all of them need to be aware of the certificates for these buckets. So we're talking like a couple 100,000 potentially certificates on just one HAProxy. So the question would be how many HAProxy or how many certificates you can have in a HAProxy until it becomes an issue. So we need to really test this and battle test this. Also, like we need to dynamically load and update those certificates because we want to not reload our HAProxy every time a customer just configures a DNS name for their bucket. The other thing that we at the moment do not allow to our customers, but we get this asked quite a lot, is like cross-DC, cross-location bucket placement. So at the moment, when a customer creates a bucket, they do not really know which cluster in which data center their bucket lives on. They only know the location, so if it is in Falkenstein, Nuremberg, or Helsinki. But what we get also asked quite often is like, hey, I really would like to have the very same bucket also in like, if they are in Falkenstein, they want to have it in Nuremberg as well, for example. So therefore, we need to come up with some solution. I mean, there's Chorus, for example. But yeah, on the other hand, it has to be kind of in time because customers do not understand that those processes are asynchronous. It's a challenge. Also, within a location, eventually we would allow customers to have like the bucket within a data center multiple times. So there we have multi-site, so this is not a big deal. But we need to manage those sync policies in a good way to don't lose track of them. So again, also like a task in itself that will obviously take some time to implement it in the right way. And the other thing we also get asked quite often is at the moment we do not use IAM, so we use the secret key and access key. And with the Rados Gateway, if you create a key for a project, this key can create and delete buckets for all the buckets within that one project. So we get questions like, can we have a read-only key that can do only read buckets but not create or delete buckets, for example. So yeah, there are things we have to do where we have to overcome those challenges. And finally, as kind of already mentioned, the new way of doing things is like do it like with STS Lite or something. We really have to look into it to make those available to our customers. But then again, other departments within Hetzner would like to have it for like virtual machines as well and for load balancers and stuff. So it's a bigger topic. It's not just, hey, Rados Gateway, have it, just enable it. No, we really want to, if we go that route, we want to enable it to the entire cloud and not just to object storage. So, and then there are, even if that was not advanced enough, we still have advanced features that are kind of within our team. At some point, we want to automatic load balance our buckets. So at the moment, it's kind of a manual process. We have a task manager for it and stuff, but yeah, we want to do it basically unintended. So we only would like to get notified if there is an issue and not if we have to migrate stuff. And also another thing that we definitely need to look into is like the predictive capacity planning. So yeah, like having more insights, business intelligence, like knowing what our customers are doing, how fast they are growing, get inputs from like accounting and stuff. That would be really helpful to like build those new clusters in time before we basically see like a 90% used cluster or something weird like this. Yeah, having this said, that was like a really high overview with some details. What are you up to? What are your challenges? What do you like to know in a little bit more detail that I can answer you?
Hi, I have a question regarding to the HAProxy you mentioned. You said you have one HAProxy, which is
No. It's not just one HAProxy, so it's a couple of HAProxies running BGP and are exposed as an Anycast service to the internet.
So Anycast, active.
Yeah.
Okay, perfect. So that was
I mean,
because of the bottlenecks.
So if you run Anycast at some point, if it's one HAProxy, it's also like 10.
Okay.
At that point, it doesn't really matter anymore.
Okay, this.
So for the sake of this talk, I just mentioned one HAProxy, and it will work with one, but obviously at scale, you should not just have one.
Okay, this will extremely shorten my question. I'm done.
Hi. One question about the bucket move. Is the bucket locked during the period of moving for the client?
No, it's not locked.
The data is always available.
So the data movement will take place, and we can look into the sync process. So if it's done, and only when it's done, we change the database entry. So for the customer, the bucket is usable while we migrate the bucket from one side to the other. The problem is, and that's also why we pick and choose buckets that do not have especially a lot of write traffic, because you have to finish the movement at some point in time that still is manageable.
Thank you.
I think over there.
Thank you. A very creative solution. I like it a lot. I'm wondering, you were mentioning basically two types of operations. So there's a day-to-day operation where it's more like resource balancing or maintenance type of operations. But you also mentioned rebalancing storms, that this might be a reason to move buckets around.
Yeah.
In that case, wouldn't that even make the problem worse because you're doing...
Kind of. So we really try to avoid bucket movement whenever possible. So we would not do this. However, when we, for example, had a customer that it's really like sensitive to IOs, for some reason we could do this preemptively for that customers. But in general, we try to avoid those scenarios at all, especially as we are kind of a cheap provider. So what you pay is what you get, basically. So we do not necessarily take care of those customers. However, we have them, and we know that we have to take care of some of them in a like more precise way than we would necessarily do for the general customers.
They're special. And an additional question: so is this a single tenant, or are you using multi-tenancy?
No, it's a single tenant setup. Simply for like complexity reasons. So that's why we do not want to go with the multi-tenancy. Especially multi-tenancy brings its own issues down the line. So for example, if you look at static websites and stuff and DNS-based buckets, then you have to code the tenant within these things as well, because that's one issue of the Rados Gateway DNS lookup. So I tried to avoid this feature.
Okay, thanks.
Yeah, well, I was wondering about, you said you try to choose buckets to move which are medium size and do not have some special features.
Yeah.
I guess the answer to my question is a yes, but are there enough buckets to choose?
So our clusters are decent sized, so a pod is 12 racks, and 10 of those are with storage servers. So yeah, it's decently sized. We have like a lot of buckets on one cluster. And also for Hetzner customers, the default is that a bucket cannot be bigger than 100 terabyte. So, so we do not necessarily have to deal with just one customer occupy an entire cluster. That's basically not possible.
Just another question. Did you also implement the BGP on routers? Do you have multiple S3 routers gateways per cluster?
Yes and no. So we use a data center fabric underneath. So it's like a BGP with multi-protocol extensions. The clusters are running IPv6 only. And every cluster member announces his host IP address to the BGP fabric. But the HAProxys themselves know each individual Rados gateway. So in the backend configuration, we have them all. So every HAProxy in a location have for each cluster a backend configured, and within these backends, there are all Rados gateways listed. So we can use this for balancing the Rados gateways, but also for maintenance. This is quite neat because you can then use the HAProxy admin command and drain a particular Rados gateway from the HAProxy and then restart the Rados gateway without interrupting customer traffic.
Mm-hmm. Okay, perfect. Thank you.
So, thank you, Ansgar. It was a pleasure having you here. Yeah, big hand for Ansgar, please.
Thank you.